about how to write code the correct way. I start with which was solid principles in front-end. My topic was solid principles in front-end frameworks, but I edited my slides whilst I was there because these are principles which apply everywhere. So, a little bit about me. I'm Rodney Mupanduki. I'm a front-end developer, UI UX designer. I'm also a student who's trying a balance between work and school. Okay, so solid principles. These are what we're calling solid principles. These are design principles. So design principles in programming are recommendations on how to write your code in a way that keeps it maintainable and flexible. So because these are recommendations, they are very abstract and there is no way of implementing them. But right on top of those principles, we've got what we call design patterns, which are the strategies for implementing design principles. We have a lot of principles. Some of them you've been applying them, but you really didn't know that I'm applying this principle. So we have drive. These are just more examples of other principles before we just dive right in. So there is drive, which is do not repeat yourself. Then there is case, not the one that you're probably thinking of right now, but this is an acronym for keep it simple, stupid. So let me now dive right into solid principles. So because this is a technical topic, I'll just try to be quick so that you don't get bored. It's a topic that you can probably go ahead and read on your own. So solid is an acronym for single responsibility, open closed, list of substitutes, interface segregation, and dependency inversion. And we'll jump right into single responsibility. So single responsibility, this principle says a class should be responsible for only one activity and only have one cause to change. So when you are writing your code, you should make sure that your class, your module, your library, or whatever it is, should be responsible for one activity and only have one cause to change. So how do you identify if your class, your module, or your library is doing way too much? You can use what we can just type the end to try to describe what your class is doing. And when you see yourself describing what your class is doing and you have to use the keyword end, then you know your class is probably doing way too much and it's time to break it. For example, if you have a calculator app, let me just describe this in terms of in a front-end perspective. If you have a calculator app, just a simple application that you're building, we can divide that. You can write all the code in one file. It still works. But when we look at it and you try to describe what it does, we've got a part that displays the output. We've got a part that is responsible for checking for doing the keypad, which the user is probably supposed to press, choosing the numbers that they want to calculate. So already we have two components. So it would be wise to break that down into two components. But you need to strike a balance between breaking down your code, because you might break it down to such a point where it's pleasing to see, but it will be way too difficult to work with. So this was just an example, which is not in a front-end perspective, but we've got an employee class that has three methods: one to create an employee, another one to calculate their salary, maybe it's based on like the hours that they have worked, Then we've got one to assign projects, so maybe projects are just assigned randomly based on your skill set. So on the right, you can see that's reflected code with 3 different classes that perform the 3 different methods. So I'll move on to the next principle, which is open closed principle. This principle states that software entities should be open for extension but closed for modification. So what does this mean? Look at, for example, the packages that we use, the NPM packages that we use. We can't edit them. We just install packages, download them, then we start using them. What we're doing, we simply extend them. We simply add more functionality on what they already do without touching that code base. So I think that's just a good example of what open closed is. So whenever we want to add more functionality on our software, if you see yourself having to go back and edit code that you already built, trying to modify it so that accommodate the new changes, then just know you are breaking this principle. It's time to probably reflect your code. Okay, so I'll move on to list of substitute principle. List of substitute principle helps to ensure that modifying one aspect of our system does not affect other elements negatively. So, according to this principle, subclasses should be interchangeable with their base classes. This indicates that assuming that class B is a subclass of class A, we should be able to present an object of class B to any method that expects an object of class type A without worrying that the method may produce strange results. I know you probably didn't understand what it means, but imagine we have a rectangle class, and it probably have methods like that. One to set height, one to get height, one to set width, and another to get the area. But changing the height also leaves the width unchanged, and vice versa. Doubling the height of width doubles the area, setting the width, then the height of vice versa, then getting the area should give you an area equal to the height you set times the width you set. But remember I said a rectangle, but a square is a type of a rectangle with just equal sides. A square is also a rectangle. So if I'm creating a square, I'm going to create a square that implements that interface. So a square is a special case of a rectangle that is equal sides. So let's revisit the assumptions that I made in the previous slide. Changing a space height or width also changes the other dimensions. Doubling the height or the width quadruples the area, which is now different from the previous. And setting the width and the height to the area that is equal to the height times height. Setting the height and the width to the area that is equal to the width times width. So even though a square is a special case of a rectangle, what the list of substitute principle says is that since the observable behavior of a square is widely different from that of a rectangle, if you go back to that previous slide, it shouldn't be treated as a subject of a rectangle. So, so basically you can see that that principle already was broken in the sense that we can't assume that a square is the same as a rectangle. So basically that's what this principle is trying to say. Then we've got interface segregation principle. What this principle says is many client-specific interfaces are better than one general purpose interface. So what this simply saying is instead of probably having one interface is what I can watch out a blueprint of something. Instead of just having one that is generalized, it is better to have specific interfaces of model. So an example is let's say we have an interface that calculates an interface for a shell that calculates volume and area. If we have such an interface and we create our square that extends or that implements that interface, is it true that a square can have a volume? It is not true, but it can have an area. So it doesn't, but the moment we implement that interface, we are forced to implement a volume method for our square. But when you look at a cube, it's another shape that we might implement that interface that we just said. But it has the volume and it can have the area. So now, how would you do it? It is wise now to create an interface that is just for volume, an interface that is for area. Then you only implement the interface for area where it applies, and you also implement the other volume for where it applies. And since we can also implement many interfaces into one class, for a class that has what these methods, we just implement what method. So we go on to the last principle. This one, you probably have to read more about it because I can't really explain it in just want to read more about it. So what it says is, according to the dependency in version concept, high-level modules should be dependent on low-level modules. Instead, both should rely on abstractions. So there are many blogs out there that have these principles where you can just go and read about it. And these are just principles that help you to write clean code. I've been part of software projects software teams where we're given a project that already exists and we're told to probably add functionality. And everyone in the team says, I think it's better we actually restart this whole project because the code wasn't written well. So it's not about just writing something that works, but you have to think about the scalability. Is it maintainable? Because you can create a project, we give you a project and you get paid. Let's say you paid $1 grand, you get paid, and you go where you go. But for the person who assigned you that project, when they want to add more functionality, when they look for another developer, they